Hello friends, this problem is from the network theory. Network theory, the topic of two-port networks. In the question, we have a one dependent source along with one resistor of value 10 ohm, another resistor of same value, then one resistor of 5 ohm. The current flowing across this 10 ohm resistor is I1 and my dependent source has a value of 20 I1. On the input side, I have a current of magnitude I1, capital I1, and input voltage is capital V1. Similarly, on output side, I have a current of I2, and output voltage is capital V2. And we need to find the Z parameter of the network. Z parameters of the network that we need to find. So the problem is clear. Now we need to find the Z parameters of the network. We know that the Z parameters of the network related to the input and output voltage as V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. So if I may find the value of Z11, so it must be V1 by I1 keeping I2 0. Similarly, if I may find the value of Z21, it must be V2 by I1 by from equation 2 keeping I2 0. So in the above network, if I may keep the current I2 is 0, then my network will be I1. And here I have the V1 and current I1. As here in this network, across this 5 ohm resistor, no current will flow because only I2 current is flowing across this 5 ohm resistor, and we have assumed that I2 is 0. So this 5 ohm will be, so this terminal will be act as the open terminal. So that's why I have ignored the 5 ohm resistor because no current will be flowing here. So this R5 ohm is not present here. As we see that the current flowing across this 10 ohm resistor is I1. So the current flowing across this 10 ohm resistor must be I1. So the total current of I1, capital I1 is equal to the, because if I can take this node, so this node the two currents are splitting, the two outgoing currents are there, one is I1 and other is 20 I1. So my capital I1 is equal to the I1 plus 20 I1, which is equal to 21 I1. Okay, so now if I may assume voltage V1 as a 1 volt for simplicity, if I may assume voltage V1 as a 1 volt assumption. So after that, if I may apply the current source across the loop 1, across this path, the current source of my path must be current source of in this path. If I name this path as loop 1, and you can see that the voltage across this dependent current source is basically V1 because there is no series resistance here. So V1 and 20 I1 is a parallel, so voltage across this current source is V1. If I may apply the KVL at loop 1. I can write down the apply KVL at loop 1. So my equations will be 1 volt of V is equal to 10 I1 plus 10 I1, which is 1 volt across this V1 and 10 I1 and 10 I1, two resistors. So it is 1 equal to 20 I1, then my I1 will be 1 by 20 ampere. And as I know earlier that my capital I1 is equal to the 21 I1, so my capital I1 will be equal to the 21 by 20 ampere. And if I may look to this network once again, then I can see that again the network, my V2 is actually equal to the voltage across this 10 ohm resistor, which is equal to the 10 I1. So V2. So if I may write the V2 as, if I may write the V2 as 10 I1, so it will be equal to the 10 times, and I1 is 1 by 20 is 10 by 20 volt V2. So now I can find out the value of Z11 and Z12, because Z11 is V1 by I1, and we have keeping the I to 0. So it will be equal to the 1 upon V1 is 1, I1 is 21 by 20 is equal to the 20 by 21 ohm. And Z21 is V2 by I1, and we are keeping I to 0. So it must be equal to the V2 is 10 by 20 and I1 is 21 by 20. So it is 10 by 21 ohm. So similarly, if I can look at the equation, right now we are just finding out the value of Z11 and Z21 because we are keeping the I to 0. Similarly, if I can keep the I1 0, then I can find out the value of Z12 and Z22. So here Z12 will be V1 by I2 by keeping I1 0, and my Z22 will be V2 by I2 by keeping I1 0. So we have the expression for Z12 and Z22. So now if we keep the I1 0, so my effective circuit will be something like that. We'll have the 20 I1 independent current source, we'll have the 10 ohm resistor, another 10 ohm resistor with the current of I1. This time we have the 5 ohm resistor also, because we are considering the I2 here. Current I2 will be flowing here, I1 here and 20 I1 here, and the voltage across this 21 will be my V1. So now if I can assume that similarly my V2 as a 1 volt, that's the last case I have assumed that my V1 as a 1 volt. So you can see that the current flowing of this branch is I1 and current flowing from this branch is 21, so it is series 20 I1. The current flowing from this branch is also 20 I1 only, so total current I2 will be 20 I1 plus I1 is equal to 21 I1, right? So if I may apply the KVL at this output loop, loop 2, name this as a loop 2, name this as a loop 1. So if I may apply the KVL at loop 1, loop 2, apply Kirchhoff's voltage law at loop 2. So I can see that my V2 is 1 volt, which is equal to the I2, which is equal to the I2 times 5 I2 plus 10 I1. My I2 is nothing but a 21 I1, so it is 10 I1 plus, so it is 1 equal to 115 I1. So my I1 will be 1 upon 115 ampere, which makes my I2, which is 21 I1, is equal to 21 1 upon 115 ampere. Now similarly, if I may apply the KVL at loop 1, so it's apply Kirchhoff's voltage law at loop 1, then it must be V1 is called V1 in the input loop. We have a voltage V1 across this 20 I1, and we have a current 20 I across this 10 ohm resistor, and an I1 across this 1 ohm resistor. But if you can see, the direction of the loop current is same with 20 I1 and this current source, but it is opposite with this I1, small I1 current, because my loop current is going in this direction, but I1 is coming this. So there must be a negative reverse sign. So then the equation must be V1 plus 20 I1 times 10 ohm resistor, but minus 10 I1, because my sign is opposite, the current sign is opposite here. So I can calculate my V1 as 10 I1 minus 200 I1, which comes out finally as 190 I1, which I can further simplify as 190 upon 115 volt. So now I have the value of V1 also, so I can calculate my Z12, which is nothing but a V1 by I2 is equal to minus 190 upon 115 upon 21 upon 115, which makes Z12 as equal to 190 upon 21 ohm. Similarly, my Z22 is equal to V2 by I2, keeping I1 0. Keeping I1 0 here, we are keeping I1 0 in this whole case. So equal to 1, V2 is I have assumed as 1, and I2 is 21 upon 115. I can find out the value as 115 upon 21 ohm, value of Z22. So my Z parameter matrix, which is equal to the, which has expressed as Z11, Z12, Z21, Z22. So I can write down my Z matrix as 20 upon 21, Z12 is 190 upon 21, Z21 is 10 upon 21, and Z22 is 115 upon 21. So correct option for this question is C. So in this question you can see that we have a network and we need to find out the Z parameters of it. So we have, first thing we have write down the equation of VOI equation for the Z parameters. Then we can see that for the finding of Z11 we need to make the I2 0. Similarly for the value of Z21 also we need to make the I2 0. And then we have followed the circuit. We have make our equivalent circuit accordingly to make the I2 0. Then 5 ohm resistor will short circuit. And similarly in the next step what we have did, we have made our I1 0, and we have calculated the value of rest two parameters, which are nothing but a Z22 and Z12, and that's how we can calculate the Z parameters of any network. Thank you.